If you travel 150 north and then travel 20 west and then 130 south and 10 east, it will look something like this. North, and then you're going to go to west, you're going to go back east, and then you're going to go back south. This is 130, 150, 20, and 10, right? So you're going north and south. First you go north. So if you're going first north and then south, you're subtracting. So you had 150 first, and then you went back to 130, which will give you 20. So your scientific notation will begin for your displacement. S with the arrow means displacement equals to upper parentheses 20x. Right? That's your first half. Now you're going to begin with your 20 west and 10. So you went 20 west and then came back east, which then gives you 20 minus 10, which then gives you 10, right? So then with that you're going to have to subtract 10y, and this is your scientific notation. No, this is your scientific notation. This is your scale unit vector notation. So your vector notation. My bad. Okay. After you get your vector notation, you're going to try and graph it. And how you're going to graph it is you first went 20 south, right? So you're going to go with your unit squares on this side. You're going to get and measure. So each square equals 0.5 centimeters. So if you have 2 squares, that would equal to 1 centimeter. So with your 1 centimeter, you're going to find your scale factor, and your scale is going to be 1 centimeter to 200 centimeters. So each 2 squares is going to equal to 200 centimeters. You're going to do 5, 1, 2, 3, 4, 5. This is going to be your 10 centimeters travel. Of course, you can't have meters on your paper, so we're doing centimeters, and that's why you transform it. From there, you're going to do 20 here. Is 10 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And since multiplying 10 times 2 gives you 20. Same thing here. 5 equals 10. So this is the distance, and this is your component vectors. Your component vectors means the change in direction, and you always have to have your arrows to show the direction that it went in. And the distance from your starting point to your finishing point is called the resultant vector, also known as your displacement. Okay, and these are your component vectors, these two. Now to find your scale factor, all you have to do is change it into a fraction, and this right here is your scale factor. After you find your scale factor, you use your order of magnitude, which your order of magnitudes are the scientific notation of 10 to the 0 power, which gives you 1, 10 to the negative 1 equals 0.1, and so on, right? And we used the order of magnitude of 2, which is 10. Yeah, 1, which is 10. 10 to the second power is 100. And we multiplied to make it bigger, we multiply 20 times 10, which gives us, 200 times 10 gives us 2,000. And then 10 times 100, yeah, right? Yeah, okay. Right? 1,000. And with the 200, we made our scale model. 200 centimeters and 100 centimeters. And put it point to the back. Okay. So with our chalkboard in the bottom, this measures up to 200, and that one measures to 100, and this right here is our displacement, which for the beginning and showing the ending point over there. And that's it.